All right, Web3. I'm sure you've heard the term, you've definitely seen the headlines, but what is it really all about once you get past all the hype? Well, today we're going to break it down because this isn't just a buzzword, it's a potential shift in the very foundation of how the internet works. So let's dive in.
This one idea right here, this is the key to understanding, well, pretty much everything about Web3. The promise isn't just about some new fancy tech. It's about a whole new way to trust. We're talking about moving away from a world that runs on a company's reputation to one that runs on pure, verifiable math.
So a math-based world, what does that actually look like, in the real world? To really get it, we first have to understand the problem that Web3 was created to solve in the first place.
And that problem, when you boil it all down, is about one thing: trust. See, almost everything we do online, from our banking to just sharing photos with friends, it requires us to put our faith in some central company to do the right thing.
Just think about it for a second. You trust your bank with your money, you trust social media with your memories, you trust the cloud with your most important files. But all of that trust is based on a promise. It's a promise from a company that could, if it wanted to, change the rules or just act in its own interest. They're the ones holding the switch to your digital life.
And this is exactly where the first big building block of Web3 comes into play: the blockchain. It's a technology that was designed from the ground up to solve this very specific problem of centralized trust.
At its core, a blockchain is really just a digital record book. But here's the magic trick. No single person or company actually owns it. It's shared and it's constantly being verified by a huge global network of computers. And that's what makes it so transparent and so secure. So, how does that even work?
Okay, let's break this down real quick. First, a bunch of transactions get bundled together into a block. Then, that block gets a unique digital fingerprint. It's called a hash. A good way to think of it is like a super secure, tamper-proof seal on an envelope. Now here's the really brilliant part. Each new block's seal is mathematically tied to the seal of the block that came right before it, and that's what forms the chain. Finally, that new sealed block is sent out to the entire network to confirm that everything looks good before it's officially added.
So, what makes this whole thing so ridiculously secure? I mean, what if somebody, a bad actor, tried to go back in time and change something? Like, say, alter the amount of money in an old transaction?
Well, this is the security genius of the blockchain. The second you try to alter anything in an old block, its unique digital fingerprint, that hash, it instantly changes. And that sets off a chain reaction, breaking the link and making every single block that came after it totally invalid. It's like a digital domino effect. To get away with it, you'd have to somehow fool and overpower thousands of computers all around the world all at the same time. It's practically impossible. The record is, for all intents and purposes, unchangeable. Or, as they say, immutable.
Okay, so we've got this unbreakable shared database. That alone is pretty revolutionary. But what happens when you start to build things on top of it? And that brings us to the next layer in our stack: smart contracts.
And our source material gives us just a fantastic way to think about these. They are unbreakable promises. A smart contract is really just an agreement, but instead of being written on paper, it's written in computer code. It lives on the blockchain, and it automatically carries out its terms when the right conditions are met. No middleman, no lawyers, nobody needed.
I mean, the difference here is just night and day. A traditional agreement, it needs intermediaries like lawyers or banks, and you're trusting their brand to do the right thing. A smart contract, it just needs code. One relies on brand trust, the other relies on pure math. One needs someone to manually enforce it, the other executes all by itself. A traditional promise can be bent or even broken. A smart contract, because it's living on the blockchain, is unbreakable.
So let's put it all together. We now have two incredibly powerful building blocks, right? We have a decentralized, tamper-proof database, and we have self-executing, unbreakable agreements. With those two things, developers can start to build a whole new generation of applications, a whole new internet. And this is where the possibilities just explode. You can build entire financial systems without needing traditional banks. That's DeFi, or decentralized finance. You can create one-of-a-kind, provably owned digital art or collectibles, them as NFTs. You can even create entire organizations that are run by code and community votes instead of a CEO. Those are called DAOs. The applications go from totally transparent supply chains all the way to video game items that you, the player, actually own.
And listen, this is not just some futuristic idea. This is happening right now.
Decentralized finance apps like Aave and Compound are currently managing tens of billions of dollars in value. And it's all happening without a central bank, governed purely by these smart contracts running on the blockchain.
So you might be wondering, what does it actually take to build all this stuff? Let's take a really quick peek behind the curtain at the basic tools that developers are using to bring these Web3 applications to life.
It really is a whole ecosystem. You've got specialized programming languages specifically for writing those unbreakable promises we talked about. Developers have these digital sandboxes where they can test out their code, and powerful frameworks to build really complex applications. And crucially, there are tools that allow a regular old website to securely talk to the blockchain, which is how we get the user-friendly apps that people can actually use.
And that brings us right back to where we started. The big idea, the main takeaway here, is this fundamental shift. We're moving from a system where we have to trust the promises made by people and brands to a new system where we can just trust transparent, verifiable code that anyone, anywhere can look at and inspect for themselves. It's that move from a brand-based world to a math-based one.
Which leaves us with a really fascinating final question to chew on. This technology is so much more than just code. It's a completely new way for us to make agreements with each other. So if our promises can truly be made unbreakable, the real question becomes, what new, incredible promises are we going to choose to make?